And then we're building up to a terawatt of solar. So that solves we'll solve the solar problem, the power generation. Tesla could become the first company in the world to build a massive solar panel factory capable of producing 100 gigawatts, or even as much as 1 gigawatts of solar power capacity every year. That's enough to power an entire country and potentially reshape the global energy landscape. And Elon Musk seems to have an almost unbelievable ambition for this factory. It could be a top-secret move to transform Tesla from just an electric car company into the company that controls the world's energy flow. So, what's really behind this massive project? And can a single factory truly change the future of the world? Everyone thinks they know Tesla's next trillion-dollar business. Some say it's robotaxi. Others are betting everything on Optimus or artificial intelligence. But while all the headlines have been chasing those stories, something far bigger has been unfolding, almost completely unnoticed. Just outside Houston, Texas, about 35 miles from the city, Tesla is quietly constructing what may become the largest solar manufacturing facility ever built. Not the biggest in the United States, not even the biggest outside China, the biggest the world has ever seen. And according to Elon Musk, this factory could eventually scale to an astonishing 1,000 gigawatts of annual production capacity, a figure so enormous that many energy analysts initially dismissed it as impossible. But here's where the story takes a dramatic turn. This isn't another bold promise or futuristic concept. Tesla has already broken ground and construction is underway. That alone raises a much bigger question. Why is almost nobody talking about it? For years, Tesla Solar was widely viewed as one of the company's biggest disappointments. After acquiring Solar City in 2016, Elon Musk painted a vision of Tesla leading the global clean energy revolution. New York invested nearly $1 billion in incentives to help build Tesla's massive Buffalo factory, expecting it to become the largest solar manufacturing hub in the Western Hemisphere. Instead, the plan unraveled faster than anyone expected. Panasonic eventually took over production before walking away in 2020. The Buffalo facility gradually shifted toward building supercharger components and processing autopilot data, while solar manufacturing faded into the background. Tesla's solar business declined so sharply that it nearly disappeared from the company's earnings discussions altogether. Then, near the end of 2025, something changed, and this time, it looked very different. Almost without anyone noticing, Tesla made a move that completely changed the conversation. At its Buffalo facility, the company quietly began producing a brand new solar panel called the TSP420, and by early 2026, it officially entered the US market. Most people dismissed the launch as nothing more than a small attempt to revive a business that had already lost momentum years ago. But as it turns out, the panel itself was never the real story. It was the first clue that something much larger had already been set in motion. That became clear only weeks later when Elon Musk took the stage at the World Economic Forum in Davos and revealed that Tesla and SpaceX would each build enough solar manufacturing capacity in the United States to reach 100 gigawatts of annual production, controlling the entire supply chain from raw materials all the way to finished solar panels. Unsurprisingly, the market reacted the same way it often does to Musk's biggest announcements. The target sounded so ambitious, so expensive, and so unrealistic that many investors simply assumed it would never happen. But then the evidence started to appear. CNBC reported that Tesla was negotiating to purchase nearly $2.9 billion worth of advanced solar manufacturing equipment from China, with all of it expected to be shipped to Texas. Suddenly, what had sounded like another impossible promise began to look a lot more like an actual construction project. Now we finally know where it's happening. In Brookshire, Texas, just outside Houston, Tesla has reportedly leased more than 1.65 million square feet of industrial space with plans to expand by several 100,000 additional square feet in the near future. Even more interesting, this is the very same location where the company is building its roughly $200 million Megapack megafactory, making it increasingly clear that these aren't two separate investments at all. They're two pieces of the same long-term strategy. What Tesla is building in Brookshire isn't just another factory. It's the foundation of what could become a fully integrated energy campus, where solar panels and Megapack battery systems are manufactured side by side as part of a single operation. On the surface, that may not sound revolutionary, but it perfectly reflects how Tesla sees the future of energy. In the company's long-term strategy, solar generation and battery storage aren't separate businesses. They're two halves of the same system. Think about it. A utility-scale solar farm becomes far more valuable when it's paired with megapacks that can store electricity around the clock. A home covered in rooftop solar reaches its full potential only when it's connected to a power wall. Yeah. That's why Tesla isn't simply trying to sell more solar panels. It's building an ecosystem where every product strengthens the value of the next, giving the company control over the entire energy chain, rather than just one piece of it. And that's exactly what makes this project so significant. Based on everything confirmed so far, the Brookshire facility isn't designed as a conventional solar panel assembly plant. Instead, Tesla is creating a vertically integrated manufacturing operation where nearly every major production step takes place under one roof, from pulling silicon ingots and slicing wafers to producing photovoltaic cells and assembling the finished panels. That level of vertical integration is remarkably rare in today's solar industry, where most manufacturers still depend on complex supply chains spread across multiple countries throughout Asia. In many ways, Tesla is applying the same strategy that transformed its electric vehicle business. Rather than relying on suppliers for critical components, the company wants to bring as much of the manufacturing process in-house as possible, giving it greater control over costs, production speed, quality, and long-term scalability. That's also why Houston makes so much more sense than many people realize. As one of the largest port cities in the United States, it provides the infrastructure Tesla would need to import billions of dollars worth of specialized manufacturing equipment from China, something Austin simply can't match. Beyond that, Houston offers an enormous industrial logistics network, a deep pool of skilled workers and the space needed to expand massive manufacturing facilities far more efficiently than most locations across the country, making it an ideal launchpad for a project of this scale. But the real shock came when people started looking at the numbers. As Elon Musk stated, Tesla will eventually build 1 terawatt of solar power, and 100 gigawatts will now be the initial target for the plant. Today, Tesla's Buffalo facility is capable of producing only about 300 megawatts of solar panels each year. So with 100 gigawatts annually, that's an increase of more than 300 times. And according to Tesla's own timeline, the company hopes to reach that level in less than 3 years. To understand just how extraordinary that is, consider the current industry leader. First, Solar, the largest domestic solar manufacturer in the United States, is expected to reach approximately 17.7 gigawatts of annual capacity by 2027. In all of 2023, the entire United States installed roughly 32 gigawatts of new solar capacity. Tesla is proposing that one factory alone could eventually produce more than 3 times the amount of solar panels the entire country deployed in a full year. That's not an incremental improvement. It's a scale the industry has never attempted before. So, it's easy to understand why so many analysts have reacted with skepticism. Calling the plan overly ambitious would almost be an understatement. Elon Musk has built a reputation for setting targets that often sound impossible. But he has also missed some of his biggest timelines. The solar roof was once presented as the future of residential construction before largely fading from the spotlight. The 4680 battery program took years longer than expected to reach meaningful commercial production. And the Tesla Semi also arrived well behind its original schedule. That's exactly why investors aren't questioning whether Tesla can build another factory. They're questioning whether any company on Earth can scale solar manufacturing this quickly without running into the same delays that have affected so many of Tesla's most ambitious projects. But this time, there's one critical difference that sets the entire project apart from everything Tesla has attempted before. Unlike the Buffalo factory, Berkshire isn't being built around government subsidies or political incentives. No state is handing Tesla a massive check in exchange for promised jobs. And there doesn't appear to be a build it first and hope it works later strategy behind the project. Instead, Tesla is putting its own capital on the line, which changes the equation entirely. Current estimates suggest the manufacturing equipment alone could cost close to $3 billion, and that's before accounting for the clean room facilities, factory construction utilities, and the massive infrastructure required to support an operation of this scale. By the time the campus is fully built out, the total investment could easily climb beyond $4 billion. That level of commitment also reveals something important. Tesla isn't making a relatively inexpensive bet on a new business. It's committing billions of dollars because management appears to believe the long-term opportunity is large enough to justify one of the biggest manufacturing investments in the company's history. And here's what makes the story even more compelling. Tesla doesn't actually have to achieve its headline target for this project to become a massive success. Even if the factory ultimately reaches only 20 or 30 gigawatts of annual production instead of 100, Tesla would immediately rank among the largest solar manufacturers in the United States. If it manages to scale to 50 gigawatts, the company wouldn't simply compete with today's domestic leaders, it would redefine the industry's competitive landscape on an entirely different scale. That's why the 100 gigawatt, while grabbing all the headlines, may not even be the most important part of the story. The real takeaway is that Tesla is building manufacturing capacity so large that even falling far short of its ultimate goal could still transform the US solar industry. And if that happens, we may be looking at the beginning of an entirely new chapter for solar manufacturing in America. But while most of the attention has been focused on Tesla's massive 100 gigawatt solar project in Texas, the company has quietly been making another move that could be just as important for its global strategy. This time, the focus isn't the United States, it's Europe. Tesla is reportedly preparing to expand its Gigafactory Berlin with a huge new facility planned just north of the existing site. Early reports suggest the new building could nearly double the factory's current footprint, signaling that Tesla's ambitions in Germany extend far beyond simply producing more vehicles. What's particularly interesting is that this expansion appears to be about much more than increasing output from existing assembly lines or hiring additional workers. Shortly after Tesla announced plans to significantly boost production at Giga Berlin, new information began pointing to a large-scale physical expansion of the factory itself, raising speculation that the company is preparing space for an entirely new generation of products. Earlier this year, Elon Musk hinted that the purpose-built Cybercab is the most likely next major product to be manufactured at Giga Berlin, with the Optimus humanoid robot potentially following later. If that happens, Berlin would become a critical piece of Tesla's international robotaxi strategy. Producing Cybercab in Europe would eliminate the need to ship vehicles across the Atlantic, allowing Tesla to deploy autonomous fleets throughout major European cities as soon as regional regulators approve commercial robotaxi operations. Although the expanded facility could eventually accommodate products like the Optimus robot or even future versions of the Tesla Semi-Cybercab appears to be the most logical near-term candidate. Tesla has already begun mass production of the vehicle at Giga Texas, and establishing dedicated assembly lines in Germany would dramatically simplify logistics while accelerating the company's expansion across the European market. The size of the proposed building also suggests Tesla is thinking well beyond a single new product. The additional floor space would allow the company to integrate entirely new manufacturing lines alongside its existing vehicle production, while continuing to ramp up on-site 4680 battery cell manufacturing, creating an even more vertically integrated operation. Those expansion plans align closely with Tesla's latest announcement that Giga Berlin will increase production by another 20% beginning in October, while hiring approximately 1,000 additional employees. Combined with the construction of a much larger facility, the production increase and workforce expansion suggests Tesla is finally beginning the large-scale growth Elon Musk has long promised for its German Gigafactory, especially after workers recently voted against a union majority in the latest Works Council election, giving the company greater flexibility to execute its long-term manufacturing plans. So what do you think could Elon Musk actually pull off one of the most ambitious manufacturing projects in history? Or is the 100 gigawatt solar factory simply aiming too high? It's hard to understand why so many people still dislike the Tesla Semi, even though it's the world's longest-range electric truck and costs as little as 15 cents per mile to operate, something no conventional Class 8 semi-truck can match. Part of the backlash may come from Elon Musk's bold promises and the repeated delays that plague the program. But now, the Tesla Semi has quietly revealed its two biggest upgrades since entering real-world production: an FSD system being prepared behind the scenes and a newly redesigned cab built to maximize efficiency. The idea of a Class 8 truck hauling freight down the highway without a driver is already sparking intense debate. We're talking about a vehicle that's longer, heavier, has more blind spots, carries far greater momentum, and often pulls a massive trailer behind it. One wrong decision could turn into a disaster. So will the Tesla Semi actually become more effective with this new capability? At first glance, the concept of a fully autonomous semi-truck seems unrealistic. The risks appear to outweigh the potential benefits by a wide margin. Yet as early as last year, Elon Musk hinted that the Tesla Semi would eventually receive full self-driving capability, claiming it would transform the truck into a money machine. And judging by the latest developments, it looks like Tesla's CEO wasn't joking. I think ultimately we'll make over millions probably of the Tesla Semi. And this is really going to be something that you'll see all over the place. And it'll also be autonomous or have the ability to go autonomous down the road. So how is FSD for the Tesla Semi actually being developed? A Tesla Semi was recently spotted near Fremont, California, equipped with a large validation rig mounted on its roof. Based on what has been shared, this setup is designed to collect highly accurate real-world environmental data, what engineers call ground truth validation. That may sound technical, but the basic idea is actually pretty simple. Whenever a Tesla drives down the road, its cameras and neural networks are constantly making predictions about the world around them. The system identifies lane markings, vehicles ahead, traffic signs, road markings, motorcycles, pedestrians, barriers, curves, merging traffic shadows, and even subtle situations that many human drivers barely notice. But to determine whether the AI is seeing the world correctly, Tesla needs a reliable answer key. That's exactly what ground truthing provides. The validation equipment records the environment with a level of accuracy that exceeds the vehicle's onboard perception system. Engineers can then compare what the AI believed it saw with what actually existed in the real world. If the vehicle misidentifies a lane, misjudges distance, mistakes one object for another, or reacts too slowly, in a particular scenario, the ground truth data allows Tesla to refine and improve the model with the Tesla Semi. However, the challenge becomes an entirely different game. This isn't a Model 3 or Model Y weighing a few thousand pounds. It's a Class 8 tractor hauling a trailer with a gross combined weight of up to 82,000 pounds. Its longer, heavier carries far more momentum, requires a much longer stopping distance, has more complex blind spots, and the consequences of every incorrect decision are dramatically greater. All it takes is a passenger car slamming on the brakes, another vehicle cutting in too closely, a slippery stretch of pavement, a short merge lane, or even a trailer beginning to sway slightly. In every one of those situations, the Semi's driving system has to understand what's happening faster and more accurately than it would in a passenger car. Because a small steering correction in a sedan might simply avoid an obstacle. On a fully loaded semi-truck, that exact same maneuver could send the entire trailer behind it swinging out of line. That's why the sighting of a Tesla Semi equipped with a ground truth validation rig has sparked so much debate. People have essentially split into two camps, those who support the technology and those who remain firmly against it. As we all know, Tesla has made significant progress with full self-driving. Over the past year alone, many Tesla owners have shared stories of FSD preventing crashes in situations where they believe an accident would have been almost unavoidable. Tesla's own safety data also suggests that vehicles using FSD experience one serious crash roughly every 5.3 million miles, compared with about one every 660,000 miles for human drivers. When it comes to Class 8 trucks, the stakes are even higher. In the United States, there are typically between 4,500 and 6,200 fatal crashes involving heavy-duty trucks each year. In many of those cases, the people who lose their lives are not the truck drivers themselves, but the occupants of other vehicles. That's exactly why Tesla is so eager to bring full self-driving to a tractor like the Semi. If the technology can consistently reduce human error in one of the largest and heaviest vehicles on the road, its impact on highway safety could be enormous. Of course, there's still no official timeline for the rollout, and it's far too early to say that the Tesla Semi will be driving itself anytime soon. But seeing these validation vehicles operating on public roads tells us something important. Tesla isn't just talking about autonomy in presentation slides. The company is collecting real-world data in real-world conditions using real production trucks. That becomes even more interesting when you look at the refreshed Tesla Semi itself. Tesla didn't simply bolt on a few extra cameras and call it an upgrade. The updated Semi features 10 exterior cameras along with one cabin-facing camera. Today, those cameras support safety features such as automatic emergency braking and lane keep assist. But from a long-term perspective, it's clear the hardware has been designed for something much bigger, giving the truck the level of environmental awareness needed to support full self-driving in one of the most demanding transportation environments imaginable. And this is where Tesla has a very different advantage over traditional truck manufacturers. Many companies can add more sensors, more radar, more LiDAR, or more driver assistance software. But Tesla is trying to do what it has already done with its passenger vehicles. Build a unified ecosystem where the software, data cameras, neural networks, and electric drivetrain all work together as a single integrated system. With the Semi, that level of integration is even more important. Autonomous driving in a heavy-duty truck isn't just about staying in a lane or following the vehicle ahead. It's also about managing vehicle mass traction trailer dynamics, regenerative braking chassis, stability, and the truck's response in emergency situations. That's where Tesla's Vehicle Dynamics Controller, VDC, is attracting a lot of attention. Recently, Dan Priestley, who leads the Tesla Semi program, shared a video showing the Semi driving on an icy test surface in Alaska, a location Tesla frequently uses to evaluate new capabilities and validate improvements to its heavy-duty truck. In the footage, the truck briefly begins to lose its line and slides slightly off its intended path before quickly regaining control. For a vehicle of this size, that's an incredibly important moment. On a low-traction surface, even a minor slide can become the beginning of a jackknife, where the trailer swings sideways and folds toward the tractor, creating one of the most dangerous situations a semi-truck can encounter. According to Tesla, 5DC uses high-resolution sensor data together with extremely precise multi-motor control to maintain track imam little size when it's it someone yes cars command and one man Sufanis even surf but why dabas up the sonic salt one and the mice outside as it should sit in under my is it always in passive mind is Sisanya obviously sound but this is was also Sabiu some common member shirkan to Bobes Jesus says it's about Mamma and Tad and to this armature what's the news Sisu one was in norm women on the mouth Blambonanem. Tennessee a more one no more down land as a man one of these will go that in a while man will not be oh. In simple terms, the system continuously monitors wheel speed, steering angle, lateral forces, and the vehicle's overall motion. It then adjusts torque delivery or selectively applies braking at individual wheels in real time to bring the truck back into a stable, controlled state before a small loss of traction develops into a much more serious incident. Here's a fact that very few people realize. On conventional diesel semi-trucks, traction control typically intervenes only after the wheels have already started to slip. It does that by reducing engine power or applying the brakes. But because the system relies on a diesel engine, a transmission drive shafts, and hydraulic brakes, there's always a certain amount of delay before those corrections take effect. The Tesla Semi is fundamentally different. Its electric motors can adjust torque almost instantaneously, allowing the truck to increase, reduce, or redistribute power with a level of precision that's measured in fractions of a second. This isn't about adding power just for the sake of performance. It's about keeping an enormous machine under control before it reaches the point where control silos. The moment one side of the truck begins to lose traction, the system can immediately reduce torque to those wheels, increase it where grip is still available, or combine those adjustments with selective braking to guide the vehicle back onto its intended path. Under normal driving conditions, most people would never notice any of this happening. But on ice, where every mistake is magnified, that advantage becomes impossible to ignore. Another detail that's easy to miss is that the trailer in the test wasn't empty. Dan Priestley explained that the trailer was carrying a load, including concrete ballast positioned over the fifth wheel and solid steel bars distributed throughout the rest of the trailer. This type of cargo has a relatively low center of gravity, making it well suited for testing. Even so, it demonstrates something important. Tesla wasn't showcasing the system with a lightweight, easy-to-control setup. It was validating the technology with a trailer carrying a meaningful real-world load. That said, it's important to keep the results in perspective. This is still a video released by Tesla, not an independent crash study or third-party validation. No control system can override the laws of physics. Road conditions, vehicle speed, payload, tire, grip, crosswinds, and even driver input can all influence the outcome. So, claims that the Semi can't jackknife should be viewed as a strong marketing message rather than an absolute guarantee. What's more important is the engineering behind it. The Tesla Semi's electric platform genuinely offers physical advantages that are difficult for conventional diesel trucks to replicate. Its battery pack sits low in the chassis, lowering the vehicle's center of gravity. Its electric motors can respond almost instantly. Torque can be controlled with far greater precision, and the software is able to coordinate the entire powertrain and stability system as one fully integrated platform instead of relying on separate mechanical systems reacting one after another. Now let's talk about some of the subtle but meaningful changes inside the Tesla Semi's cabin. The updated Semi retains its signature center seat driving position, but the dual 15-inch displays have been upgraded to 16-inch QHD screens mounted on either side of the steering column. The central seating position has always been an intentional design choice. It keeps both displays within the driver's natural field of view, eliminating the need to turn their head. It's a layout that prioritizes situational awareness over styling, a sensible approach for a truck expected to cover hundreds of miles during a single shift. Tesla describes the redesigned interior as an office on wheels, and the ergonomic improvements help justify that claim. The cup holders have been moved higher for easier access. The side storage compartments have been enlarged, and the steering wheel controls have been arranged so they can be operated intuitively with one hand. The side windows now extend farther into the door panel, making it easier for drivers to reach outside the cab, a direct result of feedback gathered during early prototype testing. The camera system has also been refined. As we mentioned earlier, the production version of the Tesla Semi uses 10 exterior cameras, down from the 26 cameras found on earlier prototypes. They're mounted lower on the vehicle in a configuration similar to the Model 3 and Model Y, and are designed to support Tesla's long-term full self-driving ambitions. Samsung serves as the exclusive camera supplier for the Semi platform. In an electric truck, the displays aren't just screens, they're the truck's operational hub. They can show navigation, battery status, energy consumption, charging information, camera feeds, safety alerts, trailer status, and in the future, potentially even interfaces related to FSD supervised. A Tesla Semi that covers 100,000 miles a year can't afford to rely on a cluttered or confusing user interface. If a driver spends just a few extra seconds searching for critical information, those seconds add up thousands of times over the truck's lifetime. And if the camera views aren't intuitive, driver fatigue increases. When maneuvering through tight depots, merging onto highways, or navigating busy port terminals. That's why the redesigned cabin isn't just about making drivers more comfortable. It's part of a much bigger equation, maximizing uptime. The reality is that a semi-truck generates no revenue while it's sitting in a repair shop. According to the figures Tesla has shared, the Tesla Semi fleet has now accumulated roughly 13.5 million miles of real-world operation. One individual Semi has already surpassed 440,000 miles. More importantly, Tesla says the fleet is achieving around 95% uptime, with approximately 75% to 80% of service issues resolved within 24 hours and nearly half addressed in less than 1 hour. A 95% uptime rate carries enormous commercial value. In freight transportation, trucks make money only when they're on the road. The more time they spend in the shop, the more money they cost instead of earning. And this is where Tesla seems to be maturing in its approach to the Semi. The early Semi models garnered attention for their unusual design, powerful acceleration, futuristic cabin, and promise to revolutionize the transportation industry. But the latest versions beginning to show a different direction, more practical, closer to logistics operations, and less like a concept car. Tesla is learning to transform the semi into a work tool, not just a technological icon.